Yeah, our next speaker is Jonas Lindemann. He will talk about interactive lectures and active learning with Python in scientific computing. Yes, the floor is yours.
Yeah, thank you very much. Thank you. So I'm going to talk a little bit on different topics today, but teaching and learning, especially the concept of active learning, which I will describe shortly here. So who am I? So I have a background in instructional mechanics, did my PhD in user interfaces for engineering application, component-based software, visualization. I'm also the director of LUNARC, which is the Center for Scientific and Technical Computing at Lund University. So we do large computers, which we run a lot of Python code on, actually. I'm also a developer. I've developed several applications in multiple languages, but mainly now in Python, I would say. I'm also a creative coder, musician in my spare time, so I do a lot of processing, Pi5 and music. But coming back to teaching, so I also did some books here so I'm author of the book called Ingenjörens Guide to Python. I also have an online book in Fortran, actually, so switching to different languages here. I also do a lot of teaching, both for graduate students, but also for PhD students. So I teach in a course called Software Development for Technical Applications, which is for graduate students in Python, where we learn how to develop a complete engineering application. And then for PhD students, I'm mostly working in the last one here is called Scientific Programming for Python and Fortran. So it's a tool where we start with Python. We'll also look at how we can combine different languages. So a little bit background on teaching, my experience through the university in teaching. So I started as a teaching assistant that a lot of people do. I started to lecture, helping out in the course that I was an assistant in. And then you started to first reuse all the old material. So we actually had plastic slides at the time when I started with this. So the first step we did was I started using PowerPoint and slides, and a lot of static slides. And it's really hard to keep students focused to 45-minute sections of teaching. So that is something that we need to kind of solve, and I hope I will, with this talk, do that. Seminars, however, in the computer lab is much more fun and interactive. You go around the students and look at the problems and their assignments, and it's fun. So can we make the lectures a bit more interesting as well, or fun? So in my spare time, I also started up coding clubs for children aged from 7 to 15. It's a concept called Coder Dojo. And in this case, you can't use boring slides. You need to make things interactive and engaging. And also, you need to really give good examples that the children can follow along. Otherwise, they lose interest and they do different other stuff. And some of the tools I've been using is Scratch. It's a graphical tool for programming. Processing, which I come back to later, which is a creative coding toolkit. I actually coded in Minecraft as well, which we used Python for the language. Those were really interesting, and a lot of the children were very engaged in that. So you can't come with Hello World in Python for children. That doesn't work. They lose interest really, really fast. So perhaps we can learn something from this. So the big problem here is that we have a lot of lectures that were static, and it's really hard. Even if you try to be engaging as a lecturer, people fall asleep. And it's not fun. We're sitting in a lecture and having the first student in a row sleeping. It's this distraction for the lecturer, so to speak. So how can we make things more interactive and engaging? So I took several pedagogical courses at university, and one topic that came up was this active learning. And the idea here is that you practice and receive knowledge learned during the lecture. So you give students the opportunity to actually try the things that you are lecturing about. So this is a an image that is often shown in this active learning here. That you remember 10% of what you read, 10%, 20% of what you hear, that's 30% of what you see, and 30% of what you hear and see. But if you go into the active learning part here, if you remember 70% of what you actually say and write, and 90% of what you do. So this is an important thing to take with us. And this thing, the whole thing with me started when I attended a software carpentry course, or instructor course. So this is a organization that teaches basic computational science tools for PhD students. They do it in quite different way. So they you encourage the student. So almost all things in software carpentry is taught interactively with live coding. So the lecturer is actually standing and coding live during the entire part. And also, you encourage the students to follow along with the coding. And you use post-it notes on your laptop computer. So if you are following along and you're okay working, you have a red post-it note. And if you're done, you put up your green post-it note. And you can follow along. And the lecturer knows, okay, now everybody's green, then I can continue. It's a bit challenging if we go to the courses that we have on at LTH. It's actually very resource intensive, and we don't have the budget for doing these courses. But there are a lot of concepts in software carpentry that we can bring with us. So I am trying to do that. So live coding, I try to do that as often as I can to actually show people what coding means and how you do it, and also show all the errors you do during the coding sessions. Also trying to implement exercises during the lecture, add quizzes into the material. So we have to find a solution here. So provide environments where the student can follow along during the lectures. That is one of the things we need to solve. And break up the lectures with the opportunity to practice the acquired knowledge. So how do we implement this? So the first step is actually replacing the PowerPoint slides. So finding an alternative to interactive finding an alternative PowerPoint that is more, this is a really strange sentence here, but okay. But we find an alternative. So now I'm actually teaching with PowerPoint here, or lecturing with PowerPoint. But PowerPoint can be used in certain ways, but for interactive teaching programming, it's not very good. So, not interactive. If you show code examples, they are often static, so you can't do anything about them. You also have to show both the code and the result, and it's not optimal. So a lot of the existing slides I had was actually code with examples. So notebooks on Jupyter Notebooks, probably have heard that, can actually show both text and code. So I've heard that this notebook alternative was available. So let's see. So I just thought, could I take this and create slides from notebooks? So just to explain here for those that don't use Jupyter Notebooks. So notebooks is actually both a document format based on JSON, so it describes both text and code. And it's an interactive computing protocol where you communicate with a computational kernel. It doesn't have to be Python, it can be R, it can be other languages as well. And the actual kernel, that is the Python interpreter, runs in the background and provides output in the notebook. You can run those locally, so if you have installed an Anaconda installation, for example, you can run it locally on your computer. But there's an alternative that is really more interesting for lectures, and it's running them in the cloud. That doesn't require your students to have access to a running Python environment. They can actually run it directly in the cloud. And what I use in my teaching is Google Colab. It's not entirely a Jupyter notebook, but it's a notebook environment in the cloud that provides similar capabilities. And it's free for free tier, works well for teaching purposes, unless you really have to do heavy stuff during your teaching. But for the things I teach, it has worked very well. And then before your lecture, you can provide a URL to the students. Here is the lecture I'm going to do. You can follow along, and you can do the same examples that the lecturer does. It requires, I think, a Google account to be able to run the notebook. You can view the notebook without an account, but I think you need an account to run it. And also you can download the notebook locally if you want to run it in your own environment as well. So if you want to try this yourself, you can actually take a photograph of this here. This will open a notebook, so you can start it up now, or so I try to bring some active learning into this lecture. So I'll leave it a bit here. And just to explain here, this is a typical notebook from my introduction lecture to Python. So to the left here, you can open up a section outline. So basically an outline that you have in your PowerPoint slides. There is also a file folder that you can see what, if your code generates files, the user can download the files from that location. At the top here, there is something called anslut in Swedish, or connect, that will create the kernel for you that runs the code. So before you can actually run anything, you need to start it up at the top there. Then I also try to provide some extra comments to the lectures, which I provide to the right side. So you can annotate your lectures with some additional but not required material, optional. So I will try to just run this notebook to show how it works. So now you can see here, now it's running here, so there is a green mark here. If I click this one here on the left, it shows you the entire lecture layout here. And you can see here you have code here mixed in. So when you lecture, you can do, okay, so if you run this code here, it produces the following output here. So you can also change here. So if I change to 8 here, you can run it again. And you can see how it affects. So you can actually illustrate changing your code and see how it affects your output. And that's really hard to do in a PowerPoint slide. And you can also see that I have the annotations here on the right side. So another thing that I learned from the courses I took is try to provide breaks in the lecture where the students actually can try out the concepts themselves. So I've thought about this a lot because it's really easy to implement this using a standalone notebook on the laptop, but you don't have really that all that possibilities in the Colab notebook. So I found out some ways to do it. So yeah, as I said, quizzes and tasks can be used to enable to practice the knowledge. You can formulate tasks in the lecture notebook at suitable places. So you leave out an empty cell block that you can let the student, okay, please solve this problem in this block. And then I place a solution part in a special block in following that. So if the students try something, they can compare with my solution as well. So and that is hidden in a special form tag. So in this case here, I have an exercise. Try yourself. Have questions here, and then you can give your. Oh, sorry, this was not an interactive notebook, so this was PowerPoint again. So I will show you that just in a minute. But here you can answer here in this cell block. You press run, and then you can click down below show code, and it will open up the solution. So I will show this here as well. So here is the actual live notebook. So I can type here. Let's see, just I have the. Need to make sure that I have imported this here. So now I can do a equals to np dot array 1 2. And then I can run the code here. And I didn't print it out, so I have to add something here. Print a run. And then, okay, what is the solution here? I can just print the code here. And now I can see this is one way of doing it. And I can also run this solution here in the notebook. So this is a way to kind of break the lecture, make it more interesting, and let the student do a certain task. And it's not limited to simple example like this. So I teach engineering education, so we implement the finite element program. And in that case, we have a larger example here, which is for generating a mesh. So the student here there's a sample code here for defining geometry. And to do, just put inside here, please add the circles here in this part. And now for this lecture, I just put the code in here. So if I run this here, it will generate a mesh that is just a square. But I want to add a circle in the middle here. So I can add a code here. So then the student can actually try it out themselves. I put it in here. And then I run the code again. And you can see here, it adds the circle. So then you can actually let the students try them out themselves. And of course, there is also the completed code here. And then you can generate the mesh, continue the lecture here, and show the final mesh here that has been generated. So it works for more complex examples as well. Another thing I fought with a lot is when I teach object-oriented programming. Usually you try to do stuff like this. You create a point and you do everything really dry with printing statements and really text-based. And it's really hard to convey what it means and how you can use it. So I was thinking about how can we make this more engaging and understandable. So then I took a note from my creative coding side, which I do in my spare time. So creative coding is a way when you code to make art or creative stuff instead of just making database queries. You do some more. So this is an example of something called sketches done with a tool called processing. You can create nice images and moving images using very little code. And there is a tool which I use called processing. It's an interactive environment for creative coding, and it uses a simplified version of the Java language. Perhaps I shouldn't say it here on Python conference. It has a large API for creating graphical applications, but it also has a Python interface. Unfortunately, only version 2. And I can show you how this looks like, this environment here. So this is a development environment. It has a very simple interface, play and stop. So when I press play here, it runs the code. And it's not very many lines of code to do this. It's very, very simple. And we can do this in Python as well. So there is actually a library called Py5, which enables you to get access to the complete processing Java API within Python. It uses JPipe for providing the functionality in the C Python interpreter. That means that I can use NumPy with optimized libraries together with a more interesting graphics API. It's very simple. Import Py5, and then you can do. There are two methods in processing. One setup that is called once, and then there is a method called draw that is called repeatedly during the run. And here you can see you can interact with this sketch here in different ways. So I changed my object-oriented part of the course. So instead of using abstract point and circle, box, line examples, we actually do classes that can draw themselves in Py5. So it's little bit more complicated, but it's 10 times more engaging. And you can let the students have this environment up front, and they can follow along when you live code. So we did a more I did a more complicated, more larger example here with particles, illustrating some of this concept. And I have this environment here. In this case, I use Visual Studio Code instead, as a live coding example here. So instead of processing, we have Visual Studio Code running a Python 5, this Py5 environment. And you can see here we have a drawable base illustrating the property concepts. There's a particle that inherits from the drawable base. We have a brown particle to illustrate that we can actually implement something that is drawable here. And you can see that I can draw here. And then we have a boundary and some other thing, particle. And when the lecture is finished, it will run here. You get something like this instead. And you can start with the basic object-oriented programming and use this instead. And you don't have to learn a lot of user interface frameworks, or it's just simple drawing commands. And it's also real time, so you can do a lot of fancy stuff with transparency and stuff like that as well. And finally, I want to show also that so I teach engineering, and we use a method called finite element, which we also provide a special Python library for implementing these kind of applications. And this application can be quite complex, large parts of code, and it's hard to kind of let students experiment with the code. So I had a master's thesis work that investigated how we can put interactivity into our code. So we have a package called Colfan for Python, which we use for teaching, and we have implemented special functions that can, instead of just defining the geometry in code, using a single line of code, it can bring up an editor which you can use during your lecture to let the students manipulate the geometry without changing any line of code. So this is a code for defining the geometry. And then at the end here, we have a CFE module here, which has a method called edit geometry J. So the geometry you created in code, you pass that along to the function, and that will open an editor. So let's see if I can find that one here. Here's a completed example here. So usually many of these codes are a bit long. And if you want to kind of experiment or let the users try out things, we have here in the beginning, let's see here where we had the code. Yeah, here. This is the code line here that enables you to, you can just leave this code line out, but you can also add it in to show the geometry. So if you run this, it will bring up, now it should be a bit larger because my retina display here messes up the Qt things. But so basically an editor here, which displays the geometry I edited in code, and I can manipulate here. And when I close this, it modifies the variable, pass it along. And then it should, yeah. Now you can see here it's a bit small, but I can. So it's a finite element problem here that I changed the geometry and very easily can let the students experiment with different geometries and different problems. So to summarize, I think it's very essential that students get opportunities to practice, receive knowledge to support active learning. And I try to integrate this into many of my lectures. And notebooks is one key to provide a very easy step you can take just to move your slides over from PowerPoint to a notebook. And you provide a URL before. Then they can actually experiment with the code you are lecturing with by themselves. And if they don't want to show it, they can just sit by themselves and try it out. Then you can also add tasks and quizzes to your lecture notes. So you can say, okay, now we take a break here and try out and change something and solve some of the problems in your lecture. Also, I think creative coding environment can have a really important part when teaching. So making things more interesting and more engaging. And also illustrate some of the concepts, for example, in object-oriented programming. You can also add functions to your existing libraries to make it easier for the students to interact with what you're teaching, so that they can try out what happens if I change the height of something, or if I put a hole inside a geometry, what happens with the stresses. And then they can modify the code, and they can also quickly change the geometry and try different things. And finally, Python is a very flexible language, especially in teaching, because it's dynamic. It has a lot of environments that provide this interactivity very easily. So notebooks and the live coding you can do, because it's a scripting language, you can actually modify the code live. And you can mix code with interactive functions. So that was my final slide. And if you want to talk to me or contact me if you have any questions about this, you can contact me on email, but also on Twitter, on GitHub, and on YouTube. So thank you very much.
Thank you very much.
Yeah.
I think most of us have taken at least one course, and some of them were not as interactive, I would say. So it's really great to see that professors are working in this direction. We have time for one or perhaps two questions. Yeah.
Cool. Super nice talk. I had a question about the interactive part, and I was thinking...
So who's talking?
Oh, sorry, I'm over here. Hey.
Yeah, okay, yeah.
Sorry. So I was thinking about when you use these collab notebooks and then having the interactive part.
Yeah.
And I was thinking that you could actually maybe have like interactive quizzes in the notebook using IPy widgets. I don't know if you ever used that before. But you could... Okay, so IPy widgets lets you you can click the cell and you can have like interactive outputs.
Okay.
So then like you could literally make a quiz, I think, in the middle of the notebook by making a script, in a Python file, import as a library, import the functions, then just put the function, and then when they click it, like an interactive quiz might pop up.
Yeah.
But you have to see what I'm talking about with the IPy widgets. But I think you could actually have that in the notebook as another quiz.
But is that available in the Colab environment as well?
It's a library, but I don't know if it works in Colab, but I think it should.
Yeah.
Yeah, but it's called IPy widgets, and it also does things with visualization and all that stuff. So it lets you go interactive in a notebook even more.
I see some, when I run it locally with a local notebook, there was a lot more options to do things. But when I went to this Google, I had a lot less options.
Yeah, I don't know if it works in Colab, but I think it will. But yeah, maybe something to try.
Thank you.
All right, last question. Thanks, really interesting. As you are someone who is in this educational space and have a lot of experience teaching us now about the exciting opportunities that we have to teachings. Looking forward maybe 3 years or something like that, what do you think the future advancements are going to be, or future like quality of life? Where do you think this space is heading?
Yeah, probably much more interaction, but also you can do more environments in the cloud that provides more rich things. For the engineering space I'm doing, it's still you have to do a lot of things locally, because it's not feasible to do the complete user interface for something in the notebook. But actually, what I see now, a lot of students turn assignments in notebooks, even the ones that are doing graphical user interface in Qt. So in the middle, they start the loop, event loop, and inside a notebook. So notebooks is very popular. It also provides some problems with the code not being executed in a certain order. So it's a bit mixed, the usage of that.
We can have one last question. Yeah.
Thank you very much for the presentation. I'm a mechanical engineer myself, and I have an engineering question. For the CalFM and the Python libraries for the finite element, does it also work with 3D analysis?
There are, yes, there are 3D elements.
Okay.
The mesh generation is not superly finished for the 3D parts, but the elements are there.
Okay.
Yeah.
Thank you.
All right.
Thank you very much.
Thank you.
Thank you.
One small remark when you mentioned the Qt. It's actually interesting, and in PyQt, what I did before is like drawing the canvas and giving like few inputs and buttons and labels, and you can actually drag like using eval, which is like, well, maybe not everybody want to like it, but you can print all the properties and drag the buttons dynamically and see the properties and all of it. Pretty fancy.
Yeah.
All right, thank you one more time.
Yeah, thank you.
All right. Thank you everybody for coming, who stayed till the end of it. It's really great to see everybody you here, and like this is the first day we enjoyed on offline conferences since 2 years online. The first day is over, but tomorrow is going to be another one. We're going to have a lot of cool talks. We're going to start tomorrow at 9 with Magnus. We're going to make another one keynote talk. We're going to have a lot of cool things tomorrow. I think 3 workshops, like 10 different talks. We're going to have a lightning talk section to which everybody can sign up. And, well, depends on the time that we're going to have. We're going to have different amount of talks tomorrow. Also, by the end of the day tomorrow, so I'm kind of encouraging you to stay, we're going to have a small so-called lottery where we're going to give, like, from one of our sponsors, free ebooks. So it kind of makes sense. And something called AfterCon, which is basically it's beer in a bar somewhere nearby, which everybody can join. I got an announcement that tomorrow there are going to be PyLady lunch. So anybody who want to join the group of like our PyLadies, they're going to be a special table during the lunchtime, so everybody can like find and enjoy the environment of that community. Thank you everybody for joining, and see you tomorrow. Don't forget to follow us on LinkedIn, Instagram, and all of our social media, all of these kind of things. I think what our chairwoman recommended today, PyConC 2022, where you can share your impressions and all of it. We're going to appreciate it because, well, everything is driven by community. So, well, thank you a lot for help, and I'll see you tomorrow.